All right, guys. All right, so this is going to be an answer key to the video problems. I'm going to do two separate ones. So this is going to be video problem number one. Mr. McSparron drops a ball off the roof. Okay, so for number one, it's asking how long does it take for the ball to fall to the ground? And so I'm going to show you how to put the video into Logger Pro to find this out. So what they're asking for here, though, first, let's write this down. They're asking for delta t. So we're going to figure out, and so we should be able to tell it by saying how long does it take for the ball to hit the ground. So delta t, what's our time? Well, let's go to Logger Pro. And I've got the videos on my desktop. You can see them right here. There's the videos. But let's go to Logger Pro. And I'm going to go to Insert, Movie. Hopefully you guys have gotten kind of used to this, this process of inserting movies. And so I've inserted the ball falling from the roof video. Now, remember I said that we don't, I'm going to make that full screen. There we go. That's nice. Okay, so we don't have to put all the dots on this video. We just have to put 2 dots on the video. So dot 1 is going to be, let's see, I want to fast forward it until right before the ball drops. Come on, Mr. McSparron, drop the ball. Drop it. Okay, right there. That's going to be, I think that's the first moment that my hands are off the ball. So I'm going to mark it. And it doesn't really matter where I mark it at. Honestly, you can mark over here on the side and it wouldn't matter. But I'm going to mark the ball. Okay, now let's grab this and let's fast forward. Okay, the ball is falling. All right. Whoop, I don't want it after it bounces. So a lot of you guys made that mistake. You kind of fast forward it and you ended up catching the ball on the bounce. We don't want it on the bounce. So I'm going to call that the moment when it hit. All right, that kind of point where I could see it compress. All right, so now that I've got my 2 marks, I'm going to auto-arrange it so I can see everything. Now, notice I've got some stuff over here on the graph. I don't really care that much about the graph. What I really care about is this table right here. So I want you to look and see I've got time listed in the table. So do you see how I've got 3.604 and 2.286? Well, 2.286 means that I let go of the ball 2.286 seconds into the video, and then the ball hit 3.604 seconds into the video. So I'm going to find the difference between those two. So I'm going to do 3.604. Oh, come on. There we go. So I'm going to go 3.604 minus, where did my Logger Pro go? There it is, 2.286. I don't know why it always does that. Sorry, guys. 2.286. Okay, and then I want to find the difference between those two. So let's go over to the calculator. I wonder if the calculator will work. Nope, still not working. That's okay. 3.604 minus 2.286. 1.318. 1.318 seconds. So that's my delta t right there. Okay, cool. So we're not going to have to go back to Logger Pro now. That's all we had to do in Logger Pro. It's really simple. But now it says based on the time it took for the ball to hit the ground, what's the height of the roof? Okay, so first thing I want to do is I know that delta t is going to be 1.318. Sorry, 1.318. So I know that's my given. Now this says what is the height of the roof? Well, that sounds an awful lot like, zoom, there we go. Like I'm looking for yi. So yi is going to be my question mark. So let's go ahead and use the yi equation. So yi equals 4.9 times delta t squared minus vi times delta t. All right, cool. Well, I know yi is my question mark. I know that I know delta t, so vi is the only thing I need to list over here still. And we know that at the very beginning of the video, the ball's velocity was 0. So now I'm just going to plug in. So I'm going to put 1.318 in delta t, and also in that delta t, and then 0 is going to go in there for vi. So I'm going to have 1.318. All right, so yi equals 4.9 times 1.318 squared minus 0 times 1.318. Well, the first thing I'm going to do right away is I'm going to see that 0 times 1.318 is just 0, so I'm not going to deal with that. And so I'm left with this over here. So 1.318 squared, I'm going to do that first. So let's go clear. Oh, look at that. Let's go times 1.318. 1.737. Cool. Whoop. You guys didn't see me do that. All right, so I wrote 1.737 in there. And now it's actually more than that. I'm not going to write the whole thing out, but I am going to leave it on my calculator, so watch. See how I left all those digits on my calculator right there? Now all I have to do is just hit times 4.9, and now I have a really accurate number, and I didn't lose any accuracy, so I've got 8.51. All right, so I've got yi equals 8.51. And that is meters. Now at the end of the video here, guys, I'm going to go outside and I'm going to actually measure that, and we'll see how close we ended up coming. Hello class, I'm up here on the roof and we are going to measure how far down it is to the ground. By the way, check it out. It's a pretty cool view up here from the roof. Yeah. And a nice pretty sunset over there. All right, so I've got my tape measure here, and you can see I've got Andrew down there. So I'm going to, let's see if I can set this right here on the edge. Cool. All right, so I'm going to run the tape measure down to him, and then we'll measure how high up we are. He's going to hold it on the ground when he gets it. Okay. So we're pulling it out. All right, yeah, so just hold that right on the ground. All right, so see, he's holding that on the ground. And then I'm gonna look right here. Cool. All right, now here's what I want you to see. Now there's 8 meters there. So we are at 8 meters and 22 centimeters. So 8.22 meters. So I forget what it was on the video, but you can see whether that's accurate or not. Thanks, Andrew. All right, see you guys. All right, now number 3, what's the velocity of the ball right before it hits the ground? Okay, so I'm looking for final velocity here. Okay, so VF, that's my question mark. So I know I'm going to use the VF equation. VF equals VI minus 9.8 delta T. All right, well, VI, I know that was 0. And then delta T, we knew that was 1.318. So I can plug in 0. I can plug, it was 1.318, right? Yep, 1.318. All right, this one's really easy. So VF equals 0 minus 9.8 times 1.318. So let's go over to the calculator. 9.8 times 1.318, 12.92. Okay, notice that's 12.91, but I want to round, so I look over to the right, and I see that's bigger than 5, so I'm going to make the 1 into a 2. Remember, if it had been smaller than 5, I wouldn't make it down to a 0, I'd leave it as a 1, so 12.92. Oh. All right, so my VF is 12.92, and that's a velocity, so it's meters per second. Oh, whoa, 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 almost messed up. negative. There we go. Negative 12.92 meters per second, because I don't want to forget about that negative right there. That's important. All right, so now there's going to be a video of me measuring on the outside. Thanks for watching.